Okay, students, we are taking a problem today that is quite a challenging one, and this question involves both the concept of matrix and limit. So the question goes on like this: let A be a matrix defined as capital A equal to 1 x by n minus x by n 1. We need to find limit n tends to infinity a to the power n. And as you know that a to the power n stands for multiplying this particular matrix n number of times, that will give us a to the power n, and we need to find out that what will happen when that n will become very large. Now generally for matrix, when we need to find out the higher powers of a matrix, we try to find out the smaller powers like a square, a cube, a4 like that, and we try to create a pattern out of it. So like here we have already calculated the a square part. So this is a mechanical calculation. You can see that a square is nothing but a into a. So a into a, as you know, matrix multiplication will give this result. Now here if you look at the matrix, you can see that the diagonal elements are same and the non-diagonal elements are opposite in sign but same in magnitude. And the same thing is happening here also in a square. The diagonal elements are same and the non-diagonal elements are opposite in sign. And when we are calculating a cube, then a cube again it is nothing but a square into a. So a square into a will give us a matrix which looks something like this. Now here, now we need to create a pattern out of it, and here the pattern is quite tricky because if you see that a square is 1 minus x square by n square, so this 1 is actually acting as 2c0, and this coefficient 1 can be written as 2c2, and here this coefficient 2 can be written as 2c1. Now for a cube, this 1 can be written as 3c0, this 3 can be written as 3c2, this 3 can be written as 3c1, and here the coefficient can be written as 3c3. So we can see that the pattern is quite tricky. Here the even binomial coefficients are appearing like 2c0, 2c2, and here the odd binomial coefficient is appearing, that is 2c1. Similarly 3c0, 3c2, and 3c1, 3c3. And we are not really bothered about these two elements because once we crack this particular element, this element will be negative of this and this element will be same as this. So following the pattern, if I want to write down a to the power n, so a to the power n will become equal to a to the power n will become nc0 minus nc2 x square by n square plus nc4 x to the power 4 by n to the power 4. Okay, in this way it will continue, and the next element will be nc1 x by n minus nc3 x cube by n cube. In this way it will continue, and it will be alternative plus minus pattern, and rest of the element we are not really bothered because it will be already obtained from the first and second element. Now you see that when n is becoming very large, when n is tending to infinity, then we need to see that what is happening to these terms, like these terms, what is where these terms are going when n is tending to infinity. So to find the limiting value, what we can do is that we can consider a generalized expression of this pattern. So if you consider a generalized expression in this pattern, and that generalized expression will be ncr into x to the power r by n to the power r. Okay, if you see all these terms, then this will be a general representation of all these terms. Now what will happen when limit n tends to infinity? So let's see that limit n tends to infinity, what will happen to this particular expression. You can see that this itself can become a limiting question. So let's try to see that what will happen. Now here you can see that this x to the power r term can be taken out of the limit because it is not dependent on n. So it will become x to the power r into limit n tends to infinity NCR, we know the definition of NCR is factorial n by factorial r, factorial n minus r, into 1 by n to the power r. So this factorial r can also be taken out. So it will become x to the power r by factorial r, limit n tends to infinity. Now you see that factorial n by factorial n minus r. As you know, factorial n is the product from 1 to n consecutive natural number, and factorial n minus r is the product of 1 to n minus r consecutive natural number. So their ratio can be easily said to be n, n minus 1, n minus 2, in this way until n minus r plus 1. Okay, and the whole thing is getting divided by n to the power r. Now this n to the power r can be distributed into r number of n, okay, in a multiplied format. So n to the power r is divided into r number of factors. Now you can see that when n is becoming very very large, these two will become equal. N minus 1 by n, this part can be written as 1 minus 1 by n. Then the next part will be written as 1 minus 2 by n. Then 1 minus 3 by n. So in this way until the last one will become 1 minus r minus 1 by n. Now as we know that when n is becoming very very large, then 1 by n, 2 by n, 3 by n, these quantities will become very very negligible. So we can take them to be 0. So this total limiting value we can see will be nothing but 1 into 1 into 1 into 1. So basically it is going to be 1. So the final result will be x to the power r by factorial r. So this is the limiting value. So we can see that this is a limiting question whose answer is x to the power r by factorial r. Now if we apply this limiting value for each and every individual term in a to the power n, then you can see that interesting thing is coming for a to the power n. So let's see, limit n tends to infinity, a to the power n will come out to be 1, NC0 is 1, minus the next one will become x square by factorial 2, the next one will be plus x4 by factorial 4. In this way it will continue to infinity. Then the next one will be x to the power 1 by factorial 1 minus x cube by factorial 3 plus x5 by factorial 5, in this way to infinity. And we are not really bothered about the other two terms. Now we can see that these are nothing but the infinite expansion of cos x, and this is the infinite expansion of sin x. Okay, so the final result we can write in this way, like this is going to be cos x sin x. Diagonal elements will become same, so we can write down cos x here, and the non-diagonal element will be opposite in sign, so minus sin x. Okay, so this is going to be the limiting value. So we can write down the limiting value to be cos x sin x minus sin x cos x. And just for information, you can see that this is an orthogonal matrix. Okay, so thank you for watching this video, and if you are having any kind of doubt, you can email me or contact me, and in the meantime you can subscribe on YouTube and you can like us on Facebook to get the video updates. Thank you very much.